Make it rain!
Hello everybody, Brad the Guitarologist. In today's video we have a Marshall DSL-100 up on the bench, JCM2000 dual super lead head. Apparently is suffering the same fate many of these heads suffer from, and that is runaway bias issues. First thing we're going to do here, we're going to remove this back panel. We're going to plug it into the variac, dial it up slowly. We'll do some checks of the bias and see if we're anywhere even in the ballpark. Here are the bias test points that we're going to be using right here. These two potentiometers on the sides here, these are for adjusting the bias, and if my suspicion is correct, those are probably not going to adjust the bias where we need it to be. Alright, I've got my probes hooked up to one side of this bias point, and I'm going to dial it up on the variac, and I'll show you what I'm looking at. I've already done some measurements here, and one side of this is way off. So I don't know if we have possibly a bad tube, or we have a problem with the board or some component internally, so in which case we're going to have to open it up and check it out. But let me show you what I'm doing here. Okay, I have my probes hooked up on this side. So my black one is hooked to the center right there, and my red, which is my positive, is hooked to the left side. This is the pot that controls this side, and this is the pot that controls this pair over here. Now the service bulletin on this, I don't have it on hand, but it does call for these to measure 90 millivolts, and we're going to see what kind of reading we get here. Let's turn on the light so you can actually see it. Okay, I'm going to dial it up just a little bit. This is not going to be all the way up, mind you. And we'll just see what this measurement does. This should start shooting up here in a second. And there it goes. And again, we're only supposed to be measuring about 90 millivolts. And we're only halfway up. And the more I dial that up, the input voltage, the more this is going to go up. But we're already up over 120 millivolts and climbing, 200 millivolts and climbing, and there's no way, and this pot is dialed all the way down. So this bias on this side is running away. Now we'll check the other side while we're at it. This one's a little closer to what it should be. This one's only down around 14 millivolts, and I can dial it up to about 30, from about 34 all the way down to practically 0, down to about 2. And once again, you know, I'm only at 64 volts on the input here. I would expect one pair of these tubes to begin displaying some signs of red plating any minute now. These on this side are cool, whereas these over here are beginning to heat up a little more. But like I said, I don't know if it's a tube failure issue or what. So here's what I'm going to do. I'm going to repeat this measurement, but I'm going to flop these pairs. I'll take these two out and put them over here, and I'll take these two out and put them over here, and we'll see if something happened right there, and then this changed. I could hear something happen in the speaker right then. And it's jumping all over the place. We've got some whistle in the output, some weird little noises. So yeah, definitely something is not right. I'm going to go ahead and go ahead and dial it back down and kill the power. But essentially what I want to do at this point is flop these two pairs of tubes around and see if the problem follows the tubes or if the problem stays with the probes. So let's dial it up about halfway first, and that should tell us all we need to know. If the problem follows the tube pair, what that's going to tell us is we have a problem with one of the tubes most likely, and we'll test those, but we should know here in just a second, and I think it's definitely going to stay with the socket. So yep, yeah, so it's starting to run away again, going way higher than it's supposed to be. So the problem is staying with the socket, so we know the problem is somewhere in the amplifier, either on the main board or on the bias board or something of that nature. So let's go ahead and pop the amp open It's very common for these Marshall DSLs and TSLs to have conductive boards. They had boards that were made at a certain time period, probably around the time this one was made. This is a 2005 according to the serial number right there. Okay, I flipped this up on the bench and we were going to remove the chassis by taking these 4 big screws out down here on the bottom. But one thing I noticed, I don't know if the customer said that he was experiencing problems with the reverb or not, but I did notice that the reverb was disconnected when I opened this thing up already. Where do you think the problem lies? Though that's R8 and R9, and I believe those are the little what they do is they put 1 ohm resistors between the cathodes of the tubes and ground in these so that you can measure the bias. And it looks to me like one of those is blown completely apart. That one on the right there. That one on the left is probably still good. I think all that's just smoke from the one on the right. But they both should be replaced. And I think that's what those are. R8 and R9. We'll check the schematic and see. And there could be a reason that one of those is blown. So there might be something else that caused that to happen. That is either the cause or is a symptom of the problem, and that's gotten us definitely within the area. But again, we don't know if that's the only problem. But that definitely is a problem, so we're going to address that. We have a board up here on top that's going to have to come out and get out of our way. And that's the bottom board, and we're not going to have to take that board out. We can service it from the top, but we do at least have to get this one out of the way. We may have to disconnect some wires to do that. And you kind of have to know where all this stuff goes back when you're putting it all back together. So if you disconnect any of these ribbon cables, you need to make sure, for instance, you put all those back in the appropriate spots, which is why it's good to have some video like this, or to at least have some gut shots of how it was beforehand, so you don't get confused if you have to take a bunch of these ribbon cables off. Okay, looking at the schematic, trying to determine what those resistors are, and in order to know for sure, you have to get the board number correct. You see that back there, JCM2000 made in England. That is the number of that particular board down there. So JCM2-60-00. So when we look at our schematic, we need to make sure we have the board number correct. Up here on the side, for instance, let's see, that's a 6300, so this is the wrong board. If you get the board wrong, you'll be looking at the wrong thing. Because see, this has an R7 and an R8 also. And, if you're just kind of not paying attention, you might think that those are supposed to be 1 meg resistors, and that's a 7 and an 8, which is confusing, but if they happen to have corresponded, that would have really been confusing. Here we go. JCM2-60-00. So this is the board we want. Okay, so surprisingly, according to the schematic, R8 and R9 really aren't related. R8 is a 1 meg grid leak resistor. So it has nothing to do with really anything of the bias, because I mean, even if that's shorted right there, that would not account for what we're seeing. R9 is up here, right over here. C5 and C6, these two are capacitors right here, feed this plate through this resistor. We have this dropping resistor, which is a 1 watt. That's our R9 that's blown its top. Okay, to get this top board out, the easiest way is just to clip. There's two zip ties right here that zip to these little points, and just clip those off, and then this whole board will come. Should be able to just bend this up out of the way. And while I'm at it, I have this board out, I can go ahead and inspect it as well, just to make sure there's no problems there. And that's definitely R9, right? So I don't see any of these associated components. What about the 220 resistor? I wonder if it's one of those. See, what was that resistor again? That was supposed to be the one it was connected to, R3. So we should be looking for R3 or R51. Am I just blind? Because I don't see them. There's R3. But R3 is not even populated. It's just a jumper wire. Okay, wait a second. Okay, these right here, these four are 53, 54, 55, and 56. C29 is probably this guy. That's C29. This is C6 and 7. This will be R2 and R3. So that's R3 right there. And it's supposed to be a 220, and that's not a 220. That's C29, C6, and C7. Were those any of the ones we needed? Yes, in fact, C6 was one, but that shows a polarized capacitor there. Well, we do know that that is a problem. So let's that's look at that. That's blown. It's blown completely apart. For whatever reason, the schematic is not jiving with this board. Anyway, let's clip it out of there, and we'll look at replacing it. Let's clean this up a bit too while we're in here. Just wipe up all signs of the explosion that happened. And while we're in here, we'll go ahead and check this resistor. I think this resistor is okay. I think what the black on that is probably from the nearby explosion. Well, it's measuring 49 ohms. Heck with it. We'll go ahead and change it also. It could be measuring that just because it's still in circuit, but we'll just be on the safe side and go ahead and yank it out of here. Alright, I think I've figured out the problem here. If we go to the 100 watt version of the DSL, let's see if I can get there. If we zoom in here to these two values, R68 and R54, that is a 1 ohm and that's a 1 ohm resistor, and basically those are between the cathodes of this pair of tubes for in the case of R54, and the cathodes for this pair of tubes in the case of R68 to ground. So what this does is it provides you a way to measure the current. Problem is they're mislabeled on this board. Actually, here is a later version, that's the 100 watt version also, and here they have these labeled R9 and R6. If we look over here, there's R6, and that is a 1 ohm. These have been mislabeled all along. Like I said, that's R9 and R6 on this version, which is actually JCM2000-60-02, but this board is not labeled -02, it's labeled -00. It's labeled just like this one, so that should be R54 and R68, but it is not. It's mislabeled, and the number matches this number, so it's very confusing. So it's a nice day, and spring's on its way, and Buddy's looking for a good place to lay one down. Found something interesting here on my front sidewalk. I'll give a prize to the first person who recognizes what that is. If you're one of my subscribers, you will probably know. So what is that right there? Okay, we're going to change these using metal film resistors as opposed to the carbon comp resistors, and they should hold up better. I'm going to go ahead and change this one over here as well. So there are the new metal film resistors installed. Those should hold up under conditions of heat a little bit better than the other ones. Alright, we got this chassis flipped back over, and now let's try this again. Alright, so we'll hook our negative lead up to the center, we'll hook our positive lead to one of the outsides, and we're going to check the millivolts reading. Okay, I'm dialing this up slowly, and I'm adjusting and dialing and adjusting. I'm checking the other side as well, and kind of doing the same thing as I dial up, because these settings were so far off that I just really don't want to just crank the thing all the way up. And okay, we're banging on 120 volts on the input. We're about at 1.5 amps. Okay, something just went. Did you hear that? Well, something has that warm smell to it. Blew a fuse on the high tension. So this is the fuse that blew, the HT fuse. So let's look at a schematic. Alright, schematic time. Here's where the fun really begins. Now R9 resistor is what blew last time. Here's the R6 that we also replaced, the other 1 ohm for the other side. What are they connected to? Well, they're basically connected just to the cathodes. They're also connected to the suppressor grid, but that's common. If we follow it on out, they're also connected to the connector that is being used for measuring. So that's probably not it, because there's really nothing to that. It's basically just 2 pots. So if the tubes are drawing too much current and it blew this resistor before it blew, maybe it also blew high tension fuses as well. I think he actually said it did blow high tension fuse before. It could be that something on this rail is shorted perhaps. So what do we have here? We have, let's see, right here we have C35, C34. We have 2 bleeder resistors here, balance bleeder resistors. Could be C38, C39 also, or one of these resistors. I'm just kind of curious why it would seem fine for a minute and then kind of suddenly go. Probably what we should do is just start checking anything that's connected to the high tension and basically start at the fuse and work our way through. So, you know, start eliminating things. We'll eliminate D4 and D6 and C41 first. I mean, these just go to ground. It could be this C41 right there. Maybe if it's heating up, it's failing. We could also check C40. So C41 and C40 are my first 2 suspects. I think the diodes will be fine. After we check C41 and C40, we'll move on down the line and see if we can determine if these capacitors are all okay. It's those 2 ceramic capacitors right down there. C41 and C40. Ceramic capacitors are, I mean, it's not going to be those. Those are likely fine. The capacitors, the big ones, the R38 and R39 are these 2. The next ones down, R34 and R35, are these 2. But I think what I want to do first is pull this board with the high tension fuse on it and inspect the bottom of this board. Then we're going to come back and probably pull this main board down here, because I want to check the bottom side. Just make sure when I put those resistors in that, you know, I didn't inadvertently drop a blob of solder on the chassis and bridge something. Or alright, so let's pull this board. And basically here all we're looking for are any obvious signs, any broken solder joints, anything that looks suspect. Also, I want to see C2 and C16 are on this. Okay, here's the underside of the board. And I don't see anything really obvious. Okay, so this side of the fuse goes to that connector, which is this yellow wire, which is going to the switch. Comes back out of the switch and goes up here to this connector, which goes through that capacitor, C2. Okay, here's the schematic for this board. At least I believe that's what I'm looking at. Here's the HT fuse. It does go through C2. Let's pull out C2 and check it. And C2 is that guy right there, and that's the high tension fuse, so that's right there on that same board. 25 picofarad. That's not right. Let's test it again. Why would it be measuring 25 picofarad? That's supposed to be 22 nanofarad. Same thing. I'm going to measure it on my other meter. 0.1 nanofarad. Well, that's certainly not right. Good one should measure 21.5 nanofarads or 22 nanofarads, what it's supposed to be. And that could have been the problem. We'll also go ahead and check this little capacitor right here, because if this other one was bad, that one looks like it might be the same value, same type, so that one could very well be bad as well. It's very, very likely that if this thing is that far off in value, that it is leaky as hell, that the ESR is high. It's just probably a bad capacitor, and it could very, very well be the problem. Okay, this one's a 223 also, so this one should be also a 22 nanofarad or 0.02 microfarad capacitor. That one's 22 nanofarad. So see, this one's measuring correct. The other one was not. So this one can go back in. The other one is going to be replaced. All right. Okay, I've got this rear board out, and I need to remove this other board, and to do that we really need to remove the tubes. Okay, I'm going to video this, so maybe it'll make it a little easier. Alright, over here in the power section we have a white to W13, and this purple is over here to W7. A little blue connector on con 14, and that's going up here to this other board. This pink one is going from the high tension fuse to W6. There is another purple one right beside it that's going to the output transformer, W5. That is the, I guess I would call that dark purple, almost dark blue. And then there's a plum that goes to W4. Then there's a white that goes to W3. Back over here we have our two reds going to W9 and W10. Okay, our other white's going to W11. I think black is going to 12. Over here we have a yellow wire over here to W2, and then we have a connector number 13 is going over there. That's the furthest one on that other board, the front board. Okay, and then we have on down the line connector 11 is going to connector 7 up here on this board, so 11 to 7. And then we have connector 9 right here, which is going to connector 11 up here. Then we have connector 10, which is the three blue ones, going to connector that's going to connector 6 up on this backboard. Connector 7 on this board goes to connector 9 up here on this front board right there. Connector 8 goes way, let's see, connector 8, you follow it and it goes way over there. Connector 4 down here is going to connector 5 up here on this board. Would have made a hell of a lot more sense if they'd have labeled this connector the same as the one that's on the other board. Would have made more fucking sense. But what do I know? Okay, connector 4, what did I just say? Anyway, whatever I just said. I just unplugged one. What was that? That was connector 6, I think. That goes up here to connector 3. Then we have connector 5, which definitely goes 5 down here on this board goes to connector 6 up here on this board. 3 on this lower board is going to connector 2 on this upper board. Connector 2 on this lower board is going to connector 1 on this upper board. Then we have a ground wire that's obviously going to the ground bus on the end. So that's W14 is the ground. Alright, so now that board drops down and out. Oh, one more connector. W1 on the lower board is also a ground, going to ground bus. So if you have an amplifier from 2005 or around that date, you may be able to find that all of that useful. If not, then you just sat through it for no reason. So here's the main board. Okay, let's remove the screws and detach it from the tray. Okay, finally. And definitely, while we have this board out of here, we are going to take every opportunity to inspect every single solder joint on this thing and make sure that we're not going to have to take it back out again. Okay, you see these connectors? You see this one here? How the solder just kind of doesn't seem to really surround the lead and kind of go up onto it like a slope. The same can be said of this one. This one right here is barely hanging on by a thread. Look at this one. That one might even be loose completely. I don't know, maybe not, but that's definitely not a very good connection. So we're going to reflow that. And there's just a bunch of them here. That's the component I soldered in right there, that one and that. So they're okay, they're a little long. Here's the other one that I soldered in, that one right there and that one. So that went in okay. I also did this one and this one. Considering I did them from the top, they're all right actually. Okay, well, here are the capacitors we want to take out first. We'll pop these out, check these capacitors, we'll check these capacitors. Okay, let's see if this first one measures that. 313 microfarads, so it's not too bad. Let's check the next one. Okay, this one's in virtually the exact same state, well within spec. Those are okay. Okay, here's one of these. This is supposed to be 100 microfarad, and it's 92 microfarad, low ESR and low loss, so that one's good. Alright, here's the final one. And same sort of thing right there. So all 4 of those capacitors are within spec. Alright, since we had to yank this board to check these power capacitors, we are going to go ahead and do some touch-up soldering on the bottom of the board. Several of these larger resistors have some solder joints that are somewhat questionable, so we're going to touch all these up. Basically anything that looks even halfway suspect is going to get some more solder here. Okay, so I think I hit just about everything that looked suspect. Go ahead and get this back in the amplifier and do some more tests. Alright, I got this main board back installed, and it's a damn good thing I made that video of where all these connectors went, because I just, I put the connectors where I thought they probably went because of where they were kind of naturally falling. I just sort of plugged them all back in and then came back and watched my video while double checking myself, and I was off on like 4 or 5 of them. Alright, next thing I want to do is take a measurement of the current draw on the high tension winding. Okay, now what I want to do, we want to measure the amperes or the current going through this connector. So I'll put one lead on the connector itself, put the other lead on the switch where it was going before. Okay, on these meters you have a couple choices. Here we have a 400 milliamp measurement fused, and here we have a 10 amp max fused. We want to go over to the 10 amp setting. So here are amps and milliamps, and what we want to do is measure current that's now going through, basically through that circuit, but also through that fuse. So this will tell us whether or not that fuse is about to blow. And, we'll dial this thing up on the variac slowly so that we're sure we don't overload anything. Alright, at the moment we're at 93 volts on the input, 0.66 amps on the primary side, and we have 0.08 amps over on the secondary side on the high tension. That's well below the fuse rating, so we're in no danger of blowing anything at this point, at least. I'm going to dial it on up, and we'll let it burn in though for a little while. I've got sound at the speaker, so that's fine, and we're still not even at 100 milliamps, so we're 1/10 of the way to blowing that fuse. There's 115 volts. 120 or so milliamps. Yeah, we're good. I think this thing is going to be just fine. We definitely I think definitely the problem was that capacitor. So interesting. Yeah, if you have a high tension fuse that is blowing, definitely check all the things that I mentioned in this video to check, and eventually you'll find it. You know, you may have to take the main board out anyway and do some touch-up soldering just to make sure there's nothing cracked, you know, no burned components. But I think that's exactly what happened. What happened was, my theory is this capacitor failed. Basically overloaded the circuit. When it did that, it drew too much current through the 1 ohm fuse on the cathode of a pair of the output tubes and burned it to hell. And basically it started with the capacitor and ended with that resistor. But like I said, we'll let this burn in for a little while. I'll go ahead and put it on up to 120 volts, and yeah, we're at 138 milliamps on the high tension side. So I do want to cycle the switch and just make sure it does what it's supposed to there, and that's exactly what it's doing. It should come back when I flip it back. It spiked up to 180, and that's what I was kind of worried about. I was going to see if it spiked up any higher than that. I'll try it a couple more times just to be sure there's not a switch issue or anything like that. 260 it measured there for a second temporarily, but it's a slow blow fuse also, so that circuit is designed to handle, again, up to, well, in excess of 1 amp. So let's go ahead and turn our attention to the biasing. This meter here is measuring the amps on the high tension circuit, and this meter is going to be measuring the millivolts on the output tubes. Let's tweak on the bias for this side. Alright, as we get this closer to where it needs to be, this is going to climb, of course. Okay. About right there is where we need that side. Let's check the other side now. And again, this should climb, but not enough to be alarming in any way. Okay, hovering right around 70 right there. Let's go back and check the other side. And it's back a little bit low, which is what I suspected, because we had a long way to go. Let's dial that up just a little bit. Okay, 71 millivolts, and we're only drawing about 200 milliamps over on the high tension fuse, which is far from anything that's dangerous. Okay, this thing's done, and we're going to give it a short test. Okay, so let's see. We got another. Something went right there. What's up with that? You know, I probably played this thing for a half an hour, good half an hour easily, last night, and there was no problem. I bet you I've blown the fuse again, and I wonder why. And the fuse has blown. Alright, so I blew another fuse inexplicably, and back inside of this thing. And I think I was mistaken on the millivolts that you're supposed to set this thing, or milliamps, the current draw, which are exactly the same. You measure in millivolts on your meter, but it corresponds to milliamps because you have a 1 ohm resistor to ground on each of these sides. So it's exactly 1-to-1 ratio. So 71 millivolts measurement also equals 71 milliamps. I have 71.5 on one of the sides that I'm monitoring here. Also have my fluke here hooked up to monitor the amps draw on the high tension. You know, I may actually plug a guitar in, but that's the state the thing was in whenever it failed last. So I think I want to put something on, at least put something on the input and play for a second here. The things on the high tension circuit that I did not check were things further down the stream. The 22 microfarad capacitor, well, all three of these capacitors that are feeding the preamp, but I have seen no spike above about 260 milliamps. So, you know, there's no dangerous current or anything like that going on here. And as a matter of fact, I could dial this, I should be able to dial this thing on up to about 80, 85, somewhere in there, not up, even up to 90. One of the service manuals that I saw before on these called for biasing each side, each pair, to 90 milliamps, which would divide up to 45 for each tube, which is within spec. It's at the top of the range for each tube, so they wanted to bias it, you know, right at the top. Well, it's been on for a minute. I want to check the other side, the bias on the other side of the other pair of tubes. That pair's at 52.6. Alright, I biased it up to 80. I just wanted to check the reading at 80, and we're only drawing 0.3 amps, so 323 milliamps right there. So that's not, it's not anywhere near the 1 amp fuse. So my theory is what happened probably was that when I kind of turned it up a little bit when I was playing around with it last time, one of these connectors, because I've only got gator clips on this speaker, and it could be, I suppose, that, and there's gator clips here as well, perhaps one of the gator clips that's hooked up to my load, you know, kind of jostled a bit and momentarily disconnected, which basically the amp saw as no load situation. And under a no load situation, yes, the high tension fuse would blow. My guess is at the moment that that's what happened whenever that fuse blew. Basically, it's like having a bad cord. So momentarily, you know, there was no connection. But here's the plan at the moment. I think what I'm going to do here is just let this thing burn in for a little while and see if it gets to a state where it does exceed the 1 amp and blow the fuse again. Let's try the other channel briefly here. Okay, so to recap, if you are troubleshooting for a high tension fuse that keeps blowing, what you want to do is you want to look at all of the components that are on the line of the high tension. There are a couple of components again on this board. There's that little C2 right there, and I think that was initially the problem. And what you want to do is you want to hook a meter up. You want to disconnect one of the leads on the switch, that's the standby switch. You put your meter in to read amps. What you want to do is basically put it in line. So you disconnect one of those so it's going through the meter so the amps can be read. You want to put a meter in line and check for the amps reading. You want to find the condition, the place at which it starts exceeding your 1 amp rating on your high tension fuse. Just for testing purposes, if you get like a 1.5 amp, that's probably not going to blow anything in the circuit like 1.5. The difference between 1 amp and 1.5 amps is enough where you'll be able to see where it's being exceeded. I don't think anything in here is not capable of taking 1.5 amps. You're definitely not going to blow your high tension winding with just 1.5 amps. It would take much more than that to blow the winding in the power transformer. So if you blew anything at all, it would be a small component, and that small component would actually smoke. So that might even give you a clue as to what the actual problem is if it did smoke. This has been running for a little while. I've dialed it up to 80 milliamps. So I think we're good to go with this. I just, I need to put the 1 amp fuse back in, because like I said, I went up to a 1.5 amp just for testing purposes, because I wanted to see what condition existed that caused it to exceed the 1 amp, and I cannot recreate the problem right now. So my theory is, whenever I was playing last time, like I said, one of these connectors for the output probably wiggled itself loose momentarily, which caused a condition where the amp did not see a load, and that's probably when it exceeded the 1 amp and blew. Alright, so that concludes our video on this 2005 JCM2000 Marshall dual super lead DSL100 head. Hope you guys have enjoyed this video. If you have, hit the subscribe button down below and hit the bell to get all notifications. And for now, y'all take care.